Hi, everybody. Welcome to our webinar today on heat pump dryers, dry clothes better. I'm Joe Wachunas with Electrify Now and New Buildings Institute. I'm here with Barb Burwell from Electrify Now. Barb is our social media guru, and she's filling in today for Brian Stewart, who is off on vacation. We have three amazing panelists today who I'll introduce in a second, but welcome on this exciting topic that I'm really excited to talk about. And I'll just say, my background might be a little different to those of you who have seen a lot of Electrify Now webinars. I'm coming to you live from my laundry room, and my computer is currently resting on my heat pump dryer. Towards the end of the show, I will give you a live tour of this heat pump dryer that we recently purchased, and I'm very excited about. But Electrify Now, just an introduction to Electrify Now. We are an all-volunteer nonprofit organization that believes that electrification is the key to a decarbonized, clean future. And we boil down our message into four easy to follow steps. One, clean up your electricity supply by putting solar panels on your roof, signing up for community solar, your utilities clean energy program. Electrify your home. Today we're talking about one piece of your home, your dryer, but there's lots of other great information on our YouTube videos. Just Google Electrify Now YouTube. You can learn about heat pump water heaters, heat pumps, resilience, anything you want. It's there on our YouTube page. Number three is electrify your ride, and we'll be talking about our upcoming webinar on this topic. And then number four is electrify everyone. And I'll just say a couple quick housekeeping things. If you want to, and we always love to know where people are coming from. If you want to put your name in the chat and where you're coming in from, we'd love to see where people are calling in from. And then also, if you're interested in a question for our panelists, please put it in the Q&A section and leave the chat for conversation. The Q&A is easier to track for our questions. Okay, so speaking of that Electrify Everyone program, we, in partnership with the Community Energy Project, have created a program that many of you have donated to over the years. We've raised thousands and thousands of dollars to buy heat pump water heaters and have them installed in income qualified homes. We've installed over 50 heat pump water heaters together. Thank you so much. This saves typical families $1,500 over the lifetime of these water heaters and avoids CO2 emissions. It's a win-win. So thank you for donating, and we'll put a link in the chat room to the Electrify Everyone program. A huge shout out to our Electrify Coalition members. These are 45 nonprofits, for-profits, trade organizations that see electrification as a path forward to a decarbonized future. If you'd like to join, I'll put my email in the chat in a second. And like I mentioned before, the EV Revolution is our next webinar. This is going to be during Drive Electric Week on September 28th at noon Pacific time. Really excited about our panelists there. We're going to have the chief editor of Clean Technica, Zach Shahan, on, along with the nonprofit Fourth. And just like today, you're going to get a live tour of my heat pump dryer. We're going to get a live tour of the Ford F-150 Lightning from Aaron Smith, who's the president of EBA. So really excited about that webinar. Join us on the 28th. Okay, Barb, so tell us a little bit about Hang Dry Week.
Yeah, hi, thanks, Joe. So Hang Dry Week is an annual week-long event to celebrate the incredible pollution and energy-saving effects of hang drying laundry. And during this week, which happens to be our fourth annual Hang Dry Week, we are encouraging everyone to hang dry their laundry. We also have many amazing volunteers and several nonprofits we're partnering with that are helping to spread the word about Hang Dry Week. So thank you so much for that. And also, so what if you want to get involved? We ask, of course, that you follow the Hang Dry movement on Instagram, and our handle is @HangDryWeek. During this week, post a picture of your laundry to Instagram, tag us, and use the hashtag #HangDryWeek. If you prefer, you can email your picture. Again, Joe will have his email in the chat box for you to use. And by sharing a photo, we'll put your name into a drawing for some great prizes, which include a drying rack, a pulley system clothesline, some groovy clothespins, and a handmade clothespin bag. I will also be posting images during the week on our Instagram feed of participants and their laundry, so keep an eye out for that. It's really fun. And also, we want to encourage people to keep the Hang Dry Week momentum going and take advantage of the rest of summer and hang dry every time you wash a load of laundry. Most people around the world do hang dry their laundry, In fact, 97% of Italians hang dry theirs. And if people in the US did the same, we could save 3% of the electricity produced in our country. So again, if you're interested, we have some great tips on the website, hangdry.org, and on the Instagram account at hangdryweek. And we would love to get you involved and see your photos and help us save energy and fight climate change one clothespin at a time. So Joe, why exactly are we talking about heat pump dryers today?
Perfect. Yeah, well, thanks, Barb. Yes, we feel like hang drying and heat pump dryers go incredibly well together. Hang drying for when it's sunny and perfect outside to dry your clothes, and then heat pump dryers during inclement weather. So just for a little background on heat pump dryers, as we talk about that, electrifying everything is a goal of Electrify Now and of many folks that are promoting the decarbonized future. And experts are thinking that in order to electrify our entire economy, we're going to need to triple our electricity supply in the upcoming decades. So we need to take the current electricity supply that we have, represented by this plug, and then we need to double that because just to electrify transportation, which we'll be talking about next month. And then we need to do that again for buildings, to electrify buildings. And at the same time, we have to make sure that we're producing electricity renewable. So all that goes into saying that we need to use electricity wisely. And this is where the heat pump comes in. And we're so excited about heat pumps because old electric resistance heating, you can think of your coils on your stove that get hot, electrons get smushed together. That is, that's last century's technology, and it's pretty inefficient. And this chart kind of shows you a little bit why. Look at these three technologies. The electric resistance water heater uses 4,000 kilowatt hours a year. And the heat pump water heater, which instead of making heat, moves heat, just like a fridge does, uses a quarter of that energy at 1,000 kilowatt hours a year. And then look for space heating. If you use electric heat for space heating, there's immense savings for if you go to heat pumps and ductless heat pumps. But as well, you can also look at an electric dryer, which is anywhere between 700 to 1,000 kilowatt hours a year of electricity. Now that's about a tenth of an average American's electricity usage, and you can cut that again by 75% or more using heat pump dryers. Guyan will check my stats on that in just a second. This heat pump technology is really critical, and the heat pump dryer is an exciting, relatively newish technology here. This is just another look that Europe currently uses about a third of the electricity. A European household uses a third of the electricity as the US. So again, we have a lot of efficiency we can use, and we can make good use of these heat pumps to get the kilowatt hours that we need. So that brings us to our heat pump dryers webinar today. So without further ado, let me introduce our guest panelists. We're going to first hear from Guyan Park. She is a Energy Star residential appliances manager, and she leads the development of Energy Star specifications for appliances, including refrigerators, dishwashers, laundry, room ACs, room air purifiers, and dehumidifiers at the U.S. Environmental Protection Agency. And that's an amazing list. Prior to her current role, Guyan worked for building performance consulting firm and the Energy Star residential new construction program. She has an MEM from the Nicholas School of Environment at Duke University and a BA from Tufts University. So Guyan will start us out, and she'll also be supported by Steve Laybourne from ICF and Energy Star during the Q&A part of the section. Steve is a technical expert and will be joining us for that part of the Q&A. From Guyan, we'll then hear from Cora Wyent from Rewiring America. She's a research associate at Rewiring America, where she's conducting important research analysis to enable rapid electrification of everything in the economy. I'll just say Cora's amazing. She's coming to us live from the summer study today, and so you can see her outside the ACEEE Summer Study, an amazing conference. Prior to Rewiring America, Cora completed her PhD in physics at Caltech, where she studied new materials for ultra-thin solar cells and performed techno-economic analysis of new photovoltaic and carbon capture technologies. She got excited about electrification as a cost-effective, job-creating, and equitable climate solution through representing the Sunrise Movement, Los Angeles, on the SoCal Building Electrification Coalition. So we're really excited about both of our panelists today. I'm going to stop sharing my screen and give it over to Guyan.
Thanks, Joe. Let me just start sharing my screen. Are you able to see my screen?
Looks great.
Great. Okay. Hello, everyone. I'm Guyong Park. Thanks for the introduction, Joe. I'm here with Steve Laybourne. I'm with the US EPA, and I'm with the Environmental Protection Agency Energy Star program. I'm the residential appliances manager, and Steve is with ICF, and he helps support the program. Joe had already mentioned that the products that I cover as part of the residential appliances portfolio at Energy Star include kitchen appliances, laundry appliances, and small residential appliances, which are room ACs, air purifiers, and dehumidifiers. Energy Star is a government-backed program on energy efficiency that has been in place for over 3 decades. The goal is to help save energy and money while protecting the environment. Energy Star is managed jointly by EPA and DOE and is a voluntary public-private partnership program between the federal government, manufacturers, businesses, utilities, and consumers. The blue Energy Star label is intended to provide a clear symbol as to which buildings, homes, and products are leaders in energy efficiency. The Blue Energy Star label has over a 90% consumer recognition, with more than 80% of people having a general understanding of what it means. To highlight the extensive reach of Energy Star, in 2020, over 300 million Energy Star certified products were purchased by consumers. And in the last year, over 56% of US households purchased an Energy Star labeled product. As I mentioned, Energy Star covers 3 areas. One is products, which is what most people know of, but most people are not aware that we also cover commercial and industrial buildings and residential homes and multifamily. In terms of products, Energy Star certification is available across more than 75 product categories for homes and businesses. Product categories that are covered include home appliances, electronics, HVAC equipment, water heaters, to commercial products like servers. So there is a wide range of products that are covered by the program. Looking specifically at residential appliances, most of the products are covered under federal standards set by the US Department of Energy, or DOE, which undertakes federal rulemakings to set or revise energy minimum thresholds, as well as water minimum thresholds where applicable, as well as developing the test procedures associated with measuring the product's energy and water use. And what Energy Star does is we reference those standards and test procedures in developing higher efficiency thresholds for those products, potentially along with some additional performance or reporting requirements to be able to highlight approximately the top 25% of models that are leaders in efficiency within their product category. Now, the Energy Star criteria are developed through an open and transparent process with our stakeholders and interested parties, where we release several drafts and full comment periods to collect feedback. Our program reviews the criteria approximately every 3 years to stay up to date with the market. And it's also important to note that Energy Star labeled products are independently certified to use less energy without sacrificing the features and functionalities that consumers are looking for. I also wanted to mention that there's one more related program to Energy Star, which is Energy Star Most Efficient. Now, this is a program that layers on additional efficiency requirements to highlight the top 5 to 10% of efficient models for consumers today who are interested in having the most efficient products in their homes. Energy Star Most Efficient recognition is mainly available for the consumer-facing products like residential HVAC, kitchen laundry appliances, and small household appliances. Moving specifically onto dryers, which is what we're talking about today, I'm going to give a little bit of background on dryers as a whole. First, by speaking a little bit about the type of dryers that are available on the market today. But first, I think it's helpful to think about the considerations that consumers think about in selecting a dryer. The first is fuel type. Clothes dryers come in both electric and gas. Obviously, for those who don't have gas available in their homes, they have to go electric. And obviously, for electrification and decarbonization purposes, the focus is on electric dryers. Second is size. Dryers come in a wide variety of capacity sizing, but in general, they're classified as either being standard or compact. Standard size dryers are defined as those that are 4.4 cubic feet in capacity and larger. But most of us don't think about cubic feet, when we think about dryers, right? We think about width and if it's going to fit in a certain space. And so when we think about standard size dryers, they're typically around 27 inches wide. And standard size dryers are the size that is most typically in a US household in a single family home. Compact size dryers are those that are smaller than 4.4 cubic feet in capacity. And in terms of width, they're around 24 inches wide. So smaller by 3 inches. Compact size dryers are those that are more typical for multifamily buildings that generally have less space for laundry. The third consideration is location. Many US homes have a dedicated laundry space that will typically have some venting infrastructure, allowing the use of a vented dryer. Other homes or many older multifamily buildings might not have venting available. So consumers can use a ventless unit in those types of homes. So keeping in mind those three factors, we can look at the type of dryers that are available on the market today. The first type is vented gas or electric dryers. Vented dryers require venting to the outside of the home through ducts. So how vented dryers work is that they use a heating element to heat up the air in the dryer drum, which evaporates the moisture from clothes. Then the hot, moist air is vented out of the dryer and then replaced with air pulled in from your laundry room or basement, wherever it is located. And then that air must be heated. So this constant heating of air, as you can imagine, isn't super efficient. There are also additional downsides to vented dryers. It pulls in AC cooled air during the summer or heated air during the winter, and then it's essentially pumped up to the outside. So your AC or furnace has to work even harder to make up for that lost air. Also, it gets really hot inside the dryer drum, which can over dry clothes and then also cause damage to the fabrics. The second type of dryer is condenser dryers, which are ventless and are typically used in homes where venting is not possible. How condenser dryers work is that air is brought into the dryer from around the unit and then passed through a condenser, which is a heat exchanger, and then used to heat up the air that is sent into the drum to dry the wet clothes. And then wet air is brought back into the condenser, which is then cooled to release the moisture into a drain pipe and then collected in a tray. And then the dry air goes into the heating side again and then heated up and back into the drum again. And that cycle continues. Compared to a vented dryer, condenser dryers use lower temperatures to dry the clothes, so the dry cycle time can be longer. But the benefit is that, cooled or heated air is not being vented to the outside, so your HVAC system doesn't have to work harder. And when we look at the US market, there really aren't that many condenser dryers available, but condenser dryers have been super popular in Europe for a long time. And the third type of dryer that we're focusing on today actually is the heat pump dryer, which is also ventless. Heat pump dryers also have a condenser, but also include an evaporator. And the heat pump dryer essentially functions, as Joe mentioned earlier, like an air conditioner or fridge in reverse. So if you think about your air conditioner, it uses cold and hot refrigerant and coils to transfer heat and move heat from inside to the outside to keep the inside cold. A heat pump dryer essentially does that in reverse, and it's a really super efficient way of drying clothes. They also dry laundry at low temperatures, and so they are gentler on clothes. And on the next slide, we'll show you a video from Energy Star that shows more in detail how heat pump dryers work. The fourth type of dryer is a hybrid heat pump dryer. So as the name indicates, it's a type of dryer that has both heat pump technology, but also has the heating element of a vented dryer, which helps increase the speed at which the clothes are dried. So they are much more efficient than your pure vented dryer, but because of the heating element, it is less efficient than a pure heat pump dryer. Okay, Joe, this is the video time.
Okay, 1 second.
Why should you upgrade to an Energy Star certified heat pump dryer? Well, if you want to get technical, let's look at the innovative way it saves energy. Notice there's no heating element and no vent. But why? A heat pump uses technology similar to an air conditioner, but operates in reverse. Air is pulled through a condenser where it is heated before entering the drum. The hot air then absorbs moisture from your clothes. Next, the damp air goes into an evaporator, which removes the moisture and collects or drains it. The real savings happen next, when that same air is pulled back through the condenser to be reheated while still warm. In other words, we save by recycling warm air instead of releasing it through a vent and using energy to heat new cold air. Now that's a good use of hot air. So remember, while on the outside this dryer may look the same as other dryers, it is special because the heat pump technology on the inside uses 50% less energy, and that's 100% great for us and the environment. Find your Energy Star certified heat pump dryer. EnergyStar.gov/HP dryer.
Thanks, Joe. Oops. Okay, let me share my screen again. Okay, is that working?
Not quite.
Not
You can
yet.
see it.
Okay, there we
Oh,
go.
yeah.
Okay. So on this slide, here are some numbers and data that just show how efficient heat pump and hybrid heat pump dryers are. And looking at the graph here, this looks at the efficiency thresholds that are required by DOE and by Energy Star, as well as the Energy Star most efficient criteria. The Energy Star levels obviously require more energy or more efficiency than DOE for clothes dryers. And then the Energy Star most efficient criteria requires significantly more efficiency than DOE or Energy Star, on average requiring about 34% more efficiency than what DOE requires. And this level is set such that looking at the currently available dryers available on the market today, that only models that are heat pump or hybrid heat pump dryers are able to meet. And what's really interesting is that when we look at heat pump or hybrid heat pump models that are available, the amount of energy that they actually use, they're quite more efficient than even what Energy Star most efficient requirements would suggest. If we look at the table on the bottom, we have listed all the various types of heat pump and hybrid heat pump products that are available on the Energy Star certified models database. For all dryer types, Energy Star currently requires all dryers to be 21% more efficient than DOE minimum standards, as listed in the second column. And then in the column over, in the third column, we have listed the efficiency requirements for models that are most efficient. So for the various categories, most efficient requires these models to be 28 to 43% more efficient than federal standard requires, which averages to be the 34% that's listed above. On the fourth column shows the actual efficiencies that we're seeing in models in the Energy Star database. So for standard sized heat pumps, we're seeing that they're anywhere from 61 to 72% more efficient than what the federal standard requires. For standard sized hybrid models, we're seeing 31 to 40% higher efficiency. So it's less than the pure heat pump systems, but because it has a heating element, but it still provides a lot of energy savings as compared to non-heat pump dryers. And then looking at the compact models, they're about 53 to 60% more efficient than what the federal standards require. So we can see that both heat pump and hybrid heat pump dryers offer significant savings when it comes to energy. So the fact that heat pump and hybrid models are so efficient is really exciting. However, we just haven't seen heat pump dryers take off here in the US. We estimate that less than 1% of US households have a heat pump dryer. In other areas like the EU, where energy is much more expensive, heat pump dryers are much more common. So I thought the numbers in terms of models available could help paint a clearer picture of what the market looks like. So looking at our Energy Star database again, we have 535 total dryer models that are Energy Star certified. This includes all the different types and sizes of dryers, and these 535 models are represented by 34 different brands. Looking at the total number of heat pump and hybrid heat pump models that are Energy Star most efficient, there are only 31 models represented by 8 brands. So that's 31 models out of 535 models in our database. Looking at the 31 models that are heat pump or hybrid heat pump, 22 of those are heat pump and 9 are hybrid. 14 of those 31 models are standard size and 17 are compact sized. And of the 14 that are standard size, 10 models are 7 cubic feet or larger. So the number of heat pump and hybrid heat pump models available on the US market today is pretty small, but it is growing. The number of models that are available today is about double the number of models that were available in 2018. So why haven't heat pump models taken off more here in the US? And a lot of that can be attributed to the fact that there isn't much demand for heat pump dryers in the US up to now because of 3 main barriers that are impacting consumer perception of these products. First is cycle time. There is this notion that heat pump dryers can have a much longer cycle time as compared to your vented dryer because it uses lower temperatures. However, to combat this and to encourage more innovation in models, Energy Star has a requirement that all Energy Star certified models must meet an 80-minute maximum time for a normal cycle, which is the cycle that has been designed to be used for a typical load of laundry. We're also seeing that some of the newer heat pump models, some of them have short dry times under 50 minutes. And some of them are as short as 35 minutes, which is equivalent to or even better than many vented dryers on the market today. Secondly, size has been a barrier. Historically, most of the heat pump models have been compact in size, so smaller than what a typical US household currently has. We saw on the previous slide that only 10 models out of the 535 total dryer models are standard size models with heat pump technology. But in recent years, we've starting to see more and more standard-sized models become available with heat pump technology, particularly as the hybrid heat pump models, there are more of those entering the market. And lastly, price has been a challenge for heat pump dryers as well. Heat pump dryers are usually more expensive than your typical vented dryers. However, we've been seeing more and more rebates for heat pump dryers becoming more available every year through utilities, which will help to reduce the cost differential between a vented dryer and a heat pump model. And we would also be remiss not to mention the Inflation Reduction Act, which was signed by the president just a week ago. And this act specifically calls out heat pump dryers as part of one of the home electrification rebates. The IRA is so new that all the parties involved, including EPA, are working right now to get the specifics and logistics figured out. But what we do know is that the electrification grants will be administered by DOE and then passed through state agencies. Timing is uncertain, but we know that it could take some time for this to roll out. As to the impact of IRA specifically on the heat pump dryer market, we'll just have to see. We believe that it'll have a positive impact, right? Perhaps creating more demand so that more heat pump models more models may be available in the future, but we'll just have to see. Also, the rebates themselves will definitely have an impact on the price of heat pump dryers, particularly for those consumers who are underserved. These rebates can make heat pump dryers more accessible price-wise. So overall, we believe that this will have a positive impact, but the magnitude of what that impact is remains to be seen. But what we do know is that when the rebates become available, Energy Star will have heat pump dryers that are available for rebate. Outside of heat pump dryers, I did want to briefly mention that Energy Star is investing more broadly in electrification, and that the EP is doing so through a new initiative called the Energy Star Home Upgrade. Energy Star Home Upgrade will feature a self-service web-based tool that will help to increase the adoption of a set of efficient electrification upgrades for key equipment that is replaced for home shell improvements. The measures include Energy Star certified clean heat plus efficient cooling through Energy Star certified air source heat pumps, super efficient hot water through Energy Star certified heat pump water heaters, smart controls through Energy Star smart thermostats, high-performing windows or smart storm windows, a well-insulated and sealed attic, and be electric ready, making consumers aware of the potential barriers and solutions to going electric, including panel and wiring upgrades and EV chargers. EPA will be advance financing of these upgrades nationally through tax credits and the rebate programs in IRA, as well as through utility programs. Specific to the IRA, there are two rebate programs. One is called HOMES, and the other one is called High Efficiency Electric Home Rebate Programs. And for both of these efforts, the Energy Star Home Upgrade can be used as a framework. And Cora from Rewiring America will be going into more of the specifics on this. And for anyone interested in learning more about the Energy Star Home Upgrade, I suggest going to the link here. And if there are any additional questions, please feel free to reach out to me after the presentation, and I can direct you to my colleagues who are working on this effort. Lastly, I wanted to highlight the Energy Star Product Finder tool. Anyone can search for a heat pump or hybrid heat pump dryer, as well as the other products that I mentioned as part of the home upgrade, or any other Energy Star certified product in the Energy Star Product Finder tool. The link is listed here on the bottom. So once you click on the product that you're looking for, the product search page will pop up, which is here to the right. And on the left of this page, there are filter selections such as price, size, features to find the product that you're looking for. Specific to clothes dryers, you can also select heat pump or hybrid heat pump as a filter. Product Finder is also tied to rebate finders, as you can see, so you can enter your zip code here on top and it'll list any utility incentives that are available for your specific area for that product. And that concludes my presentation. Thank you for your time today.
Thank you so much, Gayang, for that fantastic presentation. We're so excited for all these resources that Energy Star has. I'll talk about that in a minute. In finding my heat pump dryer, I was just on the Energy Star site all the time. So I recommend using that product finder, and just so excited about all these initiatives. So thanks so much. Gayang and Steve will be here in the Q&A portion in just a second. Let me turn it over to Cora from Rewiring America now to chat a little bit about the Inflation Reduction Act and what it might mean for heat pump dryers. Go ahead, Cora.
Great. Thanks so much, Joe. Nice to see everyone here. So I'm from Rewiring America. My name's Cora. I'm on the research team there. And today I'll be talking about the Inflation Reduction Act and heat pump clothes dryers. So I wanted to start with just giving an overview of Rewiring America. We're a nonprofit. We were founded in 2020, and our main goal is to really electrify everything in the economy. So we do some federal policy advocacy. We pushed really hard for the IRA, and we also do a bunch of research and then some private sector partnerships. So I think one really interesting number to kind of frame the importance of electrification is that a full 42% of the US's energy-related emissions come from decisions made around the kitchen table. So that includes what cars we drive, how we heat our homes, how we heat our water, how we cook our food, how we dry our clothes, and then where our electricity comes from. And we're big on numbers and data at Rewiring America. So we've actually counted up all of the different machines that you would need to electrify in the US to really get us off of the direct combustion of fossil fuels. And it turns out that 1 billion machines that we need to electrify in our homes. So of those 1 billion machines, that includes about 200 million cars, 100 million stoves, space heaters, and water heaters, and then 20 million gas-powered dryers down here, which is what we're focusing on today. So this is a lot. It seems like a big lift, and it involves every single household making decisions and being incentivized to go electric. But we just got something that will help a lot with that big lift, and that's the Inflation Reduction Act. As Gayang just mentioned, the IRA provides rebates and tax credits and grants that are really going to help everyone electrify in the US. And it helps with heat pumps, heat pump clothes dryers, electric stoves, and a whole number of electric technologies, while at the same time working on the supply side and really helping to switch our electricity sources to solar and wind and other renewable sources. So I want to talk about a couple of the specific provisions in the Inflation Reduction Act that can affect consumers in the US and sort of what this would mean for all of you, and then what this would mean for heat pump dryers specifically. So the first of those is a consumer rebate program called HERA. I won't go into what that acronym means, and it's gotten longer as the bill has gone on, but these are direct electrification rebates. The total budget for this program is $4.5 billion, and each household can get up to $14,000 for electrifying their homes. And this program is specifically designed to benefit lower and moderate income households to make sure that we don't leave those households out of the green transition. So these rebates can cover up to 100% of the cost of electrification for households making less than 80% of their area median income. And then there are certain sort of per equipment caps that can be covered. And then it can cover 50% of the cost of electrification for households making 80 to 150% of area median income. So this is what some of the rebate caps look like. So you can get up to $840 for a heat pump clothes dryer, which is a lot. So basically the way this works is that if you're in that bracket where you make less than 80% of area median income, you can get 100% of the cost of the project covered up to $840. And then if you're in that moderate income bracket, you can get 50% of the cost covered up to $840. So if the project was $1,600, you could still get that same per equipment cap. You just won't get your full project covered in that moderate income range. And then there are a whole lot of other rebates in there, including some that might help, like if you need a new outlet in your garage for your heat pump clothes dryer, there's $2,500 for rewiring. There's $4,000 for electrical panel upgrades, and then a lot of other great incentives within this program. And the way these are going to work, as Guy Young mentioned, is that the DOE is going to distribute the funds to state offices, and then those state offices will be responsible for sort of like making programs to distribute these funds. So they'll probably be available sometime next year, but we don't know exactly when. And these are designed to be point of sale rebates. So for lower income households, you wouldn't have to pay for that upfront cost of an expensive new clothes dryer. You would actually get that rebate when you buy it and not have to put up that money up front. So happy to answer more questions about that. We're super excited about this program. Then there are a couple other consumer incentives. There's the HOMES program that's focused on whole home performance-based energy efficiency upgrades. This program has a budget of $4.3 billion, and the upgrades can be up to $8,000 per low and moderate income household and up to $4,000 for other households. And heat pump clothes dryers could be one of the measures that you would put into place to reach certain energy efficiency targets and get those rebates. So that includes heat pump clothes dryers. And then there's no upper income cap on this program. So, you know, anyone of any income level can achieve that $4,000 level if they get enough energy efficiency savings in their upgrades. And then the consumer tax credits, 25C. So these, since the lower income households often don't have tax liability, this is kind of more for middle income or higher income households. And this is a tax credit of up to 30% of certain electrification upgrades. It actually doesn't include heat pump clothes dryers in as far as I know. So basically you can get this tax credit for things like heat pumps and heat pump water heaters, but then also for things that could help you get a heat pump clothes dryer. Like there's a tax credit for $600 for breaker box upgrades. And then I just want to briefly touch on workforce and manufacturer incentives in case we have any of those folks on this call. So there's also $200 million in this bill for states to develop a workforce training program to basically train contractors who are involved in energy efficiency or electrification upgrades. And then that electrification rebates program, HERA, also has a $500 installer incentive rebate for any electrification project that they don't have to pass through to the consumers. So they get incentivized just to do these electrification installs. And then for manufacturing incentives, there's an investment tax credit, 48C, for facilities that are manufacturing clean energy technologies. So, you know, this could be a tax credit that a manufacturer who's bringing heat pump, water, clothes dryer manufacturing to the US could take advantage of. And then the Department of Energy has also gotten a lot more money to give out loans for manufacturing. So both of these could be applied to heat pump clothes dryer manufacturing. So I want to highlight quickly that Rewiring America has built this calculator, and I think Joe's going to drop the link in the chat for me. This is where you can put in your zip code and your income. We don't gather any of your data. It's just for you to see. And you can see how many of these incentives in the Inflation Reduction Act you qualify for as a household. This is a really awesome tool. Like, I don't know, I didn't know what my area median income was when this tool came out. So this actually calculates that for you and tells you what you would be eligible for and what you can gain from this bill. So excited to hear your questions and to answer them, and looking forward to the rest of the webinar. And thanks for having me today.
Awesome. Thanks so much, Cora. Already a lot of questions of folks on rebates. Maybe as I'm showing my dryer in the chat room, there's lots of questions. Oh, in the Q&A. We'll collect them all in a Google Doc afterwards if we don't get to them all today. So I'm going to show our heat pump dryer live in just a second, then get to the Q&A as quickly as possible so we can have a lot of time. I just wanted to briefly put up here this little spreadsheet I made as I was looking for heat pump dryers, just to give you an idea of cost. Obviously, cost changes all the time, and so take these with a grain of salt. But this is as of the last couple of months, as my wife and I were looking for a heat pump dryer. We went to the Energy Star website. We found the certified heat pump dryers, and what I wanted to do was look at cost, and you can see most of them were over $1,000, a couple over $2,000. The one we ended up buying was the lowest price, $800. Look at the cubic feet capacity. So again, we're seeing that most of them are compact in the ones that we were looking at. There was one, the Whirlpool was hybrid. It was 7 cubic feet, but most of the others were in the 4 to 5 cubic feet. Energy Star has an efficiency score, so I was interested in that. The more efficient, I wanted a really efficient heat pump dryer. And then for those real data nerds, the estimated kilowatt hours used per year, according to Energy Star. And you can see Whirlpool, this is the hybrid one that Guy Young mentioned. It is estimated to use 400 kilowatt hours a year. Now remember, the typical dryer is, we've seen it like 700 to 1,000 kilowatt hours a year, so it's still getting great savings. But look at, most of the heat pump dryers are in the 100 to 200 kilowatt hours a year, so efficient there. We ended up going with the Insignia. I'll just show you in 1 second. It was the lowest priced option, and we wanted to see how the lowest price option would work. It's the Best Buy brand. And they didn't advertise it much as a heat pump dryer. It was mostly advertised as a ventless dryer, but it is a heat pump dryer, and it was available, readily available. So we went for it, and I'll show you it right now. So I'm going to stop sharing, and Barb, I'm going to ask you to help guide me, folks, for this live on camera, just to show up. As my wife and I were looking into the dryer, we were like, what does a 4 cubic foot, dryer drum look like? So I just wanted to show that on camera and show you what it looks like. It's not going to be too exciting, and sorry again if you get dizzy. You're in my laundry room with me here. It looks like a pretty typical dryer, and I'm going to see if I can provide some perspective from our washer. Here's our washer next to it, and the washer is the full size, and the dryer here is the more compact size. So it's a good 4 inches lower. It's a little narrower. But let's look at the drum here. If you can see inside, that's the 4.4 cubic foot. And as Christopher Diamond from NIA said in our last year's webinar, it's a compact size, but not compact drying ability. So we've gotten full loads in this heat pump dryer, no problem. It might take a little bit longer, but it hasn't been an issue at all. We've got even a big duvet cover. We were wondering if that would work. It's dried fine, sheets, you name it. So the difference, it looks like a normal dryer. The standard dry time is 75 minutes for ours. We'll find usually that a bigger load will be between 90 minutes and 120 minutes. It sounds like a normal dryer. I'll just start mine really quickly here. You might be able to hear it or not. Just got a typical dryer sound. It's currently on. I'm not sure if that's come through the mic at all. And I'll pause it there. there's a couple very small differences. The one difference here, remember it collects water through that evaporator that Guy Young talked about, and we have two options to dispose of the water. It can collect here in this container, this long container, and each dryer might be different. So this is just indicative of one dryer, of course. Or you have the option of they give you a little tube to drain your dryer. So you have a stationary tub or or we just attach ours to. Sorry, I got to move my mug here. We just hook ours into where the washer drains in the tube behind the washer, and we don't think about it. So you have two options to drain that excess water, and then otherwise it's same except. It doesn't have a vent. And let's see if I can show you this here. That is the old hole I haven't patched up yet from our old resistance dryer, but it is ventless. And so that'll be great not to have a vent going outside of our house anymore. And here's the lint trap. So that, pretty standard lint trap. And another quick difference is they do have another lint trap here at the bottom that needs to be cleaned monthly according to the instructions. And this is another lint trap, I think, around the condenser or evaporator. So that needs to be vacuumed out on a monthly basis. But otherwise, it's a pretty standard drying experience and has worked great. We've been super happy. Okay, well, I think that's great. I think if all the panelists could come on camera, let's get to our questions because we had a lot of great ones in the Q&A. And folks, keep them coming, and we'll try to get to any that we might have missed here. So I think maybe to start us off, some folks were interested in my dryer is a 240 volt plug, but they were wondering, and maybe this is for Steve and Gayung, are there any 120 volts that plug into a normal outlet?
This is Steve, I can jump in. There are a few 120 volt heat pump models. And I think I did try and answer that in the chat, and I included in there the Energy Star qualified products list where you can sort it by voltage. There's also the product finder that's in there as well, but there are a few models. When you get to the higher sizes, they, like just all dryers in general, tend to be 240 volt. But there are a handful, I think, at like 4.1 or 4.2 cubic feet.
Perfect, thanks. Barb, do you have a question?
Well, yeah, I noticed a couple people asked about coin operated or multi-family use in community rooms or small apartments. And is that something that will be made available?
Sure, yeah, this is something that has been raised to us, particularly as, we're looking to decarb and, electrify multifamily buildings. And what I will say is that currently there is no test procedure. There's no way of measuring energy for those coin operated, more like commercial type dryers at the moment, which is why there is no spec for that. But what I will mention is that we are going to be working on a residential commercial closed dryer spec pretty soon. And so we can, evaluate that as part of that and see if there are any options there.
Great, thank you.
Thanks. Cora, there were a lot of policy related questions. I don't know, did you have a chance to kind of look at them? Were there any themes that popped out to you?
Yeah, I can do a quick lightning round of answers to some of these. So I'll try to capture as many as I saw. I saw a question about, are the rebates available for new construction affordable housing? Yes, they are available for new construction too. And multifamily housing is eligible as long as a percentage of residents hit that AMI threshold. And then I saw some questions about how can you layer these programs on top of each other? The rebates can be stacked with tax credits, but rebates cannot be stacked with other federal rebates. So you can't get like the energy efficiency plus the electrification rebates. But there are no restrictions on layering with local rebates, at least from the federal level. So if your local rebates let you stack with federal rebates, you should be able to do that. The rebates are not retroactive, so it'll basically be when these programs get put into place, from my understanding, and the tax credits start on January 1st of next year. And then one more here that I'll try to answer. Can renters access the rebates and tax credits? If you're in, my understanding of this, and I think it remains to be seen what DOE guidelines are, but renters should be able to access the rebates for something like a window unit, heat pump, or a clothes dryer if you're a renter and you have a washer dryer in unit that you're responsible for. So that's sort of a lightning round of policy answers, and feel free to keep them coming and I can answer more specific questions.
Great, thanks so much, Cora. Why don't I launch into a question then, Barb, if you have one handy. A lot of our very intelligent viewers were interested in the refrigerants. Any heat pump will use refrigerant, and they were interested in more low global warming potential refrigerants. Steve and Guyon, can you talk about that related to heat pump dryers?
A little bit. I believe I'm a little bit less familiar with the refrigerants and heat pump dryers, but I believe that it's not currently covered under SNAP. And so there is no alternatives that are listed. But what I can say is that for the manufacturers that are submitting, getting their products certified, they have the option to list it as part of their certification, and that refrigerant is listed. If that refrigerant is shared with, is part of their submission, then that will be listed on the product finder tool for that product. Steve, do you have anything more to add there?
Yeah, and I'm not sure about the product finder, but on the Energy Star qualified products list, there is a column indicating the refrigerant type, but also the global warming impact. So there are a few that are, well, more than a few. There are some that are in the lower GWP refrigerants, and then there are a few that are higher.
I was just doing a deep dive on the Energy Star website. And I do know that there was a checkbox that does say which ones on the finder do have the lower global warming potential refrigerant as well. I think it's a reminder that all our products are at the end of their life. We always need to make sure that we recycle the refrigerant and don't release it. And like we always say at Electrify Now, we are there's a lot of research going on for lower global warming potential refrigerants, and we're really excited about that. But let's not stop that from getting us all to be on electrifying as quickly as possible is our line of thinking. Barb, any other questions?
Yeah, someone asked whether there are schedules available that list and define what the different income levels or like the medium levels and how they're defined.
That's a great question. So I've learned actually at this conference this week that for the definition of area, median, and income, it's actually not defined yet what the area is going to be. Is it going to be the county or the zip code? So I don't think there's a great schedule on that yet. We tried to kind of approximate in our calculator. So if you want to look at our calculator, you can kind of tell whether you're considered area, median, income. And I think we use some definitions from the Department of Housing and Urban Development. So I'll see if I can find that resource and share that in the chat or the Q&A.
Thank you.
Great. Jim from Washington is wondering if there are any mold issues since it's ventless. And Guyoung and Steve, I don't know if you can speak to any concerns around mold with heat pump dryers.
There might be a couple. Well, I'm not sure what area they might be talking about. If they're concerned about the fact of you have to drain the water. It's so the heat pump dryers are a closed system. So if you either are dumping out the water or you have the hose to drain it out. I mean, it's just water. It's not like hot mist or anything. So it shouldn't be an issue there. I will say, the conventional dryers, they're pumping out through the vent out the home, this like hot, moist air. So if anything, that's going to be more of a culprit of probably like creating mold. And I will also say, because have been answering a lot of questions. I admit I haven't been exactly listening, but if anybody hasn't mentioned this, I'll say, you know, the vented dryers, you know, not to put off alarm bells, but like vented dryers, there has been like fire concerns there, and you don't have that with a heat pump or a ventless dryer. So a little bit off topic there, but wanted to add that in.
That's a great point. I think yeah, there might be more mold in your conventional dryer than heat pump dryer, and of course, yeah, the fire risk of dryers you really reduce, if not eliminate them, with heat pump dryers. Great, yeah. Barb, any other questions you're seeing?
Yeah, well, another one was regarding the hybrid. And does the hybrid allow a selection of when electric heaters in use, and to kind of decide whether to do the heat pump or the electric?
Yeah, Steve, do you want to take that on? I'm assuming that it's, you know, they're thinking it might be like the, you know, hybrid or heat pump water heaters where you have the choice. I'm not sure if that's available in the hybrid heat pump models or not.
You know, I can't speak for all of them, but I do think some of them, they do have a like an option or a button to like extend it. It's basically you know, the cycle time. So they probably communicate it as the cycle time. So if it's okay to go for a longer cycle, then it will just do the heat pump. If you want it shorter, then it will have that heating element kick on and shorten the cycle time.
Yeah, I would assume though, like in the tested mode, which is the normal cycle, that it would be, you know, predominantly heat pump as much as possible.
Great, thank you.
Jim had a quick question for me. If he, you know, he's seeing in his conventional dryer that it exhausts a lot of lint outside, and wondering if the heat pump dryer exhausts any lint. Anecdotally, we have not noticed any lint in our heat pump dryer usage. Steve or Gayang, I don't know if you have any other thoughts about whether lint.
Well, you know, I think related to, you know, we were talking about the lower temperatures in the heat pump dryers, which cause less damage. And I think part of that is the lint and things like that, you know, is part of the damage that's happening to the fabric. So I would assume because it is gentler on your clothes with the lower temperatures, there would be potentially less lint.
Yeah, I would agree with that. I think, admittedly, I think this was the lint is still in, there is still lint in the system. And I think if you go back like a decade ago, when the first heat pump dryers were coming out to the market, there were some issues with that where it would get sort of clogged in the system. But now manufacturers have made a lot of improvements and come out with some innovation there. In fact, I believe there are a few models on the market now where the system itself will automatically sort of flush out the lint filter, so you don't have to clean it out every single time. Obviously, you know, go by what the manufacturer recommends on how to use it, but that is a feature for some of the heat pump models that takes sort of one step out of what you normally have to do with a conventional dryer.
Great. Barb, do you have a ready question? And then we'll probably.
Well, there's an interesting one from a policy question from a nonprofit builder. And they understood that the IRA tax credit is a direct pay to nonprofits, but have only heard about this in relation to solar. And will there be any other tax credits available for direct pay if you're a nonprofit builder?
That's a great question. My understanding is that the direct pay to nonprofits is just for solar. I'm not sure if anyone else has better information about that, but I can try to look into that.
That's what I understood as well. Yeah. And then Gayang and Steve, maybe as a, you know, some folks were asking about stackable dryers or combo dryers. Is there anything you guys want to say on those available option for heat pump dryers?
Yeah, I can say that on the Energy Star website, product finder, or the qualified products list, there is an indication if it's like the product is paired with a washer. So if there's it can come as a paired washer and dryer. You will want to check on like the retailer or manufacturer website if it's stackable. Most of the ones that are paired, well, many of the ones that are paired are stackable, but not necessarily all of them. So you'll have to check with the manufacturer or retailer for that. I can say that there are some stackable heat pump dryers. For example, I've seen the Bosch at somebody's apartment, so I know at least that one, and I think a few others, maybe the Miele. But yeah, there are stackable heat pump dryers.
And I should also mention that there are some laundry centers that
Yep.
that have the heat pump dryers incorporated as part of that. The laundry centers, you typically see them, in the smaller units that have the dryer on top and the washer on the bottom. It's actually one product, but there are some new products that are out that look like a stacked pair that have a heat pump on the bottom.
Yep.
Fantastic. Well, it's really exciting to see, as Ga-Young said, the products have doubled in the last 4 years, and with the IRA that Cora walked us through today, I think we'll be seeing a lot more models on the market. And you can take from my experience, it's a fantastic technology to use in the winter when it's not sunny and you can hang your clothes outside. Hope you join us for Hang Dry Week. Thank you so much to our panelists today, Steve, Ga-Young, and Cora. Thanks to Barb for co-moderating. Thanks to you all for joining us. There were a lot of questions we didn't get to. We'll try to shoot those to our panelists and get some written responses. We'll send out the video and slides probably tomorrow, and it'll be up on our YouTube page as always. So thanks again to everyone, and good luck on your electrification projects.
Thanks.
Thanks, everyone.
Thanks.